In this video, I'll show you how to remove an acetal and reform your carbonyl, which is going to be reactive. Now again, remember these are for ketones and aldehydes only. So starting from the acetal, we're again going to be working under acidic conditions, but remember what I said last time. This time, I'm going to reverse my colors. This time, we're driving the water on, and we're driving the acetal off. So blue is going on, yellow is coming off. We're controlling this by, dumping a bunch of water in to drive the equilibrium to the right. Now, the electrophile and nucleophile, the nucleophile and electrophile, are both weak. They're just partially negative, partially positive, nothing particularly reactive. So we need an acid catalyst to get things going. We're going to again be working under H2SO4, HCl, whichever one you choose. And we're going to activate the electrophile, just like we did with putting on the acetal or forming the acetal. Okay, now you might be very, very tempted, right? We just did our acid-base chemistry. We might be very tempted to go, oh, I want to drive on the water, right? Oh, but that's not what we want to do. Why? We're in that same predicament. The carbon we want to attack and put that blue water onto is sp3 and pretty hindered. Okay, there's already something inside that can help us free things up. And our internal assistants are down and out. Since we're going backwards in the mechanism, down and out is what's going to help us next. This is going to form a carbonyl-like species that's activated, right? My electrophile is activated. And the carbon that I can attack now, my electrophile carbon, is sp2. That's much better. Flat, trigonal planar. So let's come in with the water. Water is what I'm driving on. Again, this is reversible. I usually get students ask, well, couldn't this oxygen come in and kick the electrons up? Of course it can. That's why I have reversible arrows. Right? This is a reversible reaction, but I want to draw the forward direction getting to the carbonyl, and I'm controlling this through Le Chatelier's equilibrium principle. So I am going to have the water now attack in an in-up, remembering that I am driving off these oxygens, helps me remember which direction I'm going into. I'm just going to move this to the side since I brought the water in on the right-hand side. These are the ones I'm driving away. Water is what I'm driving on. Well, at this point, the yellow oxygen, the one left clinging on, is not in a good position to just leave as an O-. You don't want to generate O- under strongly H+ conditions. So we're going to do a little proton shifting. Proton transfer. Again, remember, this is just organic chemistry, people's way of cleaning things up and making a nice, tidy, good-looking mechanism. It's not that the actual blue hydrogen is shifting over. The medium has H+ all over the place and conjugate bases to pluck from and pull from and add to. So understand that this proton transfer is just for our own purposes. Activating the yellow, activating our yellow oxygen. And now we're almost there. All we have to do is down and out again, internally assist and push it out. And we're pretty much there. We've kicked out the ethylene glycol, the antifreeze, if you will. It really is just antifreeze, ethylene glycol. and we've reformed our carbonyl. Now the carbonyl, you can say, well, it's got that proton on it. Yeah, that's because we're still under acidic conditions. When you're all done with this reaction, you would work it up under some mild base just to neutralize and remove that extra proton, revealing your final carbonyl. And you know, ketones and aldehydes are neutral, so you're probably going to want to add a base to neutralize your medium anyway. So there you have it. That's how you can reverse out of an acetal and reform your highly reactive carbonyl species.